Good afternoon. I'm Tian. I'm a geomorphologist, by which I'm a person who studies the shape and form of landscapes. Oops.
Other way.
Other way. Here it goes. So the particular landscape that I'm interested in are rivers. More specifically, I'm studying the shape of their channels. Why do I study channels? Let me use the Houston highways as an analog here. The highways in Houston allows vehicles, people, and cargo to go to different parts of the city. Well, in this picture here, nothing's moving at all, which is typical for this time of the day in Houston. Good and well-designed highways make transportation more effective, which sometimes occurs in Houston. Similarly, river channels act as nature's highway. They transport water, sediment, nutrients from upstream to downstream and to different parts of the floodplain. In turn, these floodplains are enriched with nutrients and they flourish with plants, animals, and eventually people. Some of the earliest civilizations are born on floodplain. For example, ancient Egypt was born on the floodplain of the Nile River. However, unlike highways, which more or less is standard, rivers come in many shapes and forms. Sometimes they have a single channel. Others have multiple channels. Sometimes they carry sand, or they carry gravels in their channels. Highways are designed by engineers, but who sets the shape of river channels? This is an important question to ask because the shape of river channel determines how much water it can contain during floods. Today, tens to hundreds of millions of people live on the floodplain, so they're all under some risk of flooding. By answering this question, we can inform engineers to build more effective levees to prevent catastrophe like Hurricane Katrina. So, my field site, the Selenga River in Russia, is a great place for this type of research. This river drains into Lake Baikal in Siberia. This is the deepest lake in the world. It is over a mile deep. My river contains all the type of channels that I mentioned earlier. So we can study what sets their shape just in one geographic location. So first let me show you how channel forms. Let's look at a valley from cross-sectional view instead of the aerial view. So this valley is filled with loose sediment. Then it starts to rain. And water collects in low relief areas and flows downstream due to gravity. The movement of water mobilizes the loose sediment and a small portal channel forms. Over time, the movement of water and sediment make this channel deeper and wider. Eventually, the channel stops growing because it reached a stable geometry to contain all the water and sediment it received during floods without spilling. So let me show you what I mean by spilling here. Every river has a flood season. It's a period of time when the river receives a lot of water and sediment from its upstream basin due to rainfall or snowmelt. The flood travels downstream as a wave. And when the wave arrives at a particular location, let's say our valley here, the water level in the channel increases. At the peak of the flood, the water level is the same height as the levee. If we increase the water a little more, the whole valley will be flooded. However, this normally does not happen because channel grows to a dimension to contain its own floods. So in summary, the shape of river channel is a function of the water and sediment it receives. So in another way, the shape of river are set by their own floods. It's kind of like humans can decide exactly how many lanes of highways are needed to accommodate the given traffic of a city. So this theory works really well for rivers like this, where the channel and the floodplain are made of similar material. But as you can see, this river are small and normally occur in mountain regions. For big rivers like our beloved Mississippi, the channel and the bank are made of different material. So perhaps, the bank sediment size can also change the shape of river channel. So to test this hypothesis, I traveled to Russia and to investigate my river. Here's a picture of me working in the field, collecting some data. Let me just remind you, this river in Russia contains bank and bed sediment size that varies by a factor of 1,000. So based on the data I collected, I found that river channels with small bank sediment size tends to be deeper and narrower than river channels with coarser bank sediment, which are shallow and wide. And based on these observations, I developed a new empirical relationship that considers bank sediment size to better predict shape of river channels. Understanding the shape of river channels have great implication of flood control. Therefore, my research has both basic and applied meaning. For example, during Hurricane Harvey, Buffalo Bayou flooded out of its bank. This means it received more water than its stable channel shape. However, because its levees are constructed artificially, it cannot self-adjust its shape to the new flood regime. So it is up to us to act as nature's engineer to make the appropriate change before the next big flood. Thank you for your attention.